This problem involves implementing a recursive function. We're asked to write a method called parenthesize that takes a couple of parameters, a string and an integer n, and it puts together a brand new string that has that original string with n sets of parentheses around it. So for example, if we're asked to parenthesize the string Joe Blow with 2 sets of parens, we end up with a brand new string that has the text with 2 left parens and 2 right parens. If we're asked to put 5 sets of parens around hello, we end up with 5 left parens, 5 right parens around that text hello. It would be possible to ask for 0 sets of parens, in which case we just get the original string, 1 set of parens, which might be kind of a simple case. We are told that if we're passed a negative number, that's an illegal case, and we're supposed to throw an exception, an illegal argument exception in that case. I've set up a JGrasp file that we can use for testing. It just makes a call on parenthesize, printing out the answer for each of these 5 different cases. So our task is to write a public static method called parenthesize. It's creating a new string that it returns, so the return type will be string for this parenthesize method, and it takes 2 parameters, some original text and an n. So we could have a string that we could call text and an integer n as our parameters, and then we're supposed to fill in the details here. Now, if we were allowed to use loops, we could just have some kind of a for loop, for example, that would build up a string by surrounding a current string with a new left paren and a new right paren, and just do it n times, and then return that string that we get. But we're specifically told we're supposed to solve this problem recursively. So when you solve a problem recursively, you want to be thinking in terms of different cases. There's actually a lot of good information in this table here that shows us lots of different possibilities. There's lots of places to begin. I think I'm going to begin with what you might call the degenerate case, the illegal case, where it would be passed a negative number, and we're supposed to be throwing an illegal argument exception in that case. So I'm going to say if n is less than 0, that's that illegal case. And then we're supposed to throw a new illegal argument exception. So that's what we're supposed to do in that case when n is a negative number. And we can say else if, now we want to be thinking about other cases. So in the legal cases, we may have to put a bunch of parens around something, 5 parens in this case, 2 here. We want to be thinking in terms of a base case. What's a very simple case? This case of putting 1 set of parens around a string is a pretty simple case, so you might think of making that your base case. But even simpler than that is this 0 case. And in fact, that's one that's right on the boundary there. When we have a negative n, we throw the exception. And then right on the other side of that boundary is the 0 case. So it makes a lot of sense that that would end up being our base case. And what we said is that when we're asked to do 0 sets of parens, well, then we just return the original string. So we can say else if n is the 0 case, then that's the really easy case where we can just return the text that we were passed. No parens to put around this. And otherwise, we want to solve the problem. If you were thinking iteratively, you might think else, well, I'll have a for loop. But of course, we want to try to think of this problem in a recursive way. So you want to think about how does the case of 2 parens relate to the case of 1 paren, which relates to the case of 0 parens. And in the same way that if we wrote a loop, we could go through a loop n different times, adding 1 set of parens each time. What we can do is to use recursion to do something very much like that. So we could say otherwise what we would want to be returning is a string that puts a brand new set of parens. So we can have a left paren, we can have plus something that we'll fill in, plus a right paren. We can basically put 1 set of parens around some text. So we'll be doing with our recursive call what we'd be doing each time through our loop is kind of dealing with the next set of parens. And so the question becomes, what would we want to have here? Well, if we were asked, say, to have 5 sets of parens around a string, and we were putting one of the sets of parens ourselves, what we'd like to have is a string that has 4 sets of parens. Then this becomes the 5th set. How would you do 4 parens? Well, you'd surround it with parens around something that had 3 sets of parens. And basically what we want is another call inside of here on parenthesize, where we want to parenthesize that original text, but we want n minus 1 sets of parens. So if we were asked to do 5 parens, we recursively do 4, and then we're adding the 5th set of parens ourselves. The call that involves creating a string of 4 sets of parens would recursively do a call on 3 of them and then add parens around that, which would make a call on 2, etc. You want to make sure that all of our cases are covered. So for example, this case on 1, do we still need a case for 1? Well, think about what will end up happening. If we end up calling weird science passing it 1, what will end up happening is it'll say, put a set of parens around a call on parenthesize of the text with 1 minus 1 or 0. And in the 0 case, we just get the original text. So it actually works even in that case when n is 1, because it's building on that 0 case where there are no parens at all. But of course, what you'd want to do is test it. And so I can go ahead and complete this code. Let's go ahead and make sure that it compiles properly, which it does. So then we can go ahead and run the program, and we end up getting Joe Blow with the 2 set of parens, hello with 5, fun with 0, weird science with 1, and then an illegal argument. So that's what we were expecting in that last case where we were passing a negative number. So that ends up being our solution to the problem.